Hey everyone, my name is Chris, and today we're going to talk a little bit about dealing with merge conflicts via GitHub. So, you guys are going to be using Git for version control and GitHub to share and work with others collaboratively throughout the MIDS course and potentially throughout your data science career. Now, GitHub, as you've started to see, is very useful. It lets you track a project, and anyone on your team can upload files, make changes to files in a way that can instantly be downloaded to anybody else's work. So you can move your project forward, seeing what other people are doing, and having the most recent version, ready at your availability whenever you want it. Now, this works really well, except for when two people try to change the same bit of code at the same time. You can imagine GitHub and Git, these automatic tools, don't really have the ability to interpret which of you is correct. And actually, you might need to stop and think about it and talk to your teammate and figure out what they were thinking to come up with the right solution when this issue occurs. So I'm going to walk you through 3 different examples of a simulation where we have 2 computers both connected to the same repository to give you an idea of what kinds of conflicts can occur, situations without conflict, situation with conflict, and show you how to resolve these on your own. So let's get started. I have my command line, my shell here, and I've also opened up just a folder to visually show you in the GUI what we're doing as we go. I think it'll be a little bit more intuitive for some people who are newer to the command line. I'm using Windows 10, but this should work for any system, any architecture you're working with. But we'll go from there. So let's start by setting up the simulation. I'm going to make 2 directories, and I'm going to call them Computer 1 and Computer 2. And this is just going to be a convenient way to pretend down here at the bottom that we have 2 different computers hooked up to the same GitHub repository. Now, we obviously need a repository. I'm going to use the GitHub Playground from the MIDS W18 course. Everyone in the course should have access to this. And let's just clone into it. We'll grab the URL to the clipboard, and we'll change directories into each of the computers. And we'll do git clone, and we'll paste the link. So we'll do that now. Computer 1 is now set. We'll change directories. And remember, if you use 2 dots, you go up a level. So I'm going to go up a level and then back down to Computer 2. And I'm going to do the same. Instead of typing the command, I'll just hit the up arrow on my keyboard and cycle back in. And now you see in Computer 2, GitHub Playground is loading. And we're going to have this GitHub Playground, 2 different versions of it on our 2 simulated computers. So let's clear that out. Now, looking through this repository, there are a bunch of different files. Let's create a new file that we're going to work with in this exercise. For this purpose, I've just created a file in Notepad++, which is a text editor that we can work with. Here it is. Here's a sample file. Here is a line. Here's some fake code. And we're going to pretend that this is our Python code or whatever code that we've written. And let's save it to our directory. And I'm just going to call this merge example.txt. Okay? So let's close this out. We don't need it anymore. So now we can see in Computer 1, we have this new file, merge example. But Computer 2, we don't have anything yet, right? This is a change only on one person's computer. So let's go ahead and change directories into Computer 1, where we are now. And we can see that by running git status, there's a file that's new that isn't being tracked by version control. So let's do our standard process and add it and see what this looks like for Computer 2. So we'll do git add. We'll use the period command, which just means add everything because I don't want to bother typing merge example. We'll do git commit to commit it to version control and leave a little message. We'll call it created merge example. And now we're ready to push it to GitHub. Git push. And our terminal will communicate with the repository, send the item up, send the file to the cloud, and there we go, all set. So let's clear out, and now let's change directories back to Computer 2. All right, so here we are in Computer 2, and as you can see down below, we don't have the merge example file. Now, one great thing for you to do whenever you start working in a new repository is to actually run the git fetch command. Now, git fetch does not change anything locally in your repository, but what it will do is it will look to the cloud and see if anything has changed there. And that can let you proactively know that you need to update your local repository before you start making any changes. So in this case, git fetch found that there was one thing different. And we sort of see here visually in git shell, we have this little red on the master, but really you can run git status to get a better reading on this. And here we see, we have found out via git fetch that our branch is behind the master by one commit and can be fast forwarded. What does this mean? Well, it tells us, we can just use git pull to update things locally. So let's do that. And you'll see that this has gone and gotten merge example from the web, and now here it is on computer 2. So this is sort of the best case scenario. Nobody's been editing the same file. Person 2 looked to see if anything had changed before they began working to make sure they were up to date. This is really clean. Now, unfortunately, this isn't what's always going to happen in your workflow. Things get messy, things get more complicated. So let's do 2 examples. One example where both people modify different parts of the same file, and then another example where they modify the same part of the same file. So you can see what both of these situations will look like. So let's clear the command line, and I'm just going to make these changes manually because it's a little bit faster. Let's, for computer 1, add a new section of code. This new analysis was really cool. Okay, so we'll save that, close out. For person 2, notice we don't have that new line up here. Person 2 is going to edit actually at the end. I want to add more stuff to this message. We'll say to this code. Okay, save that. So now both of these computers have different versions of merge example. Let's see what's going on. So we're just going to go back to person 1, CD computer 1. And really, whenever you're syncing with GitHub, the second person to try to sync is the one who's going to realize there's a problem and need to fix it. So person 1 here can run through the normal progression, git add, git commit m, add a new analysis to top of code, git push. And all of this will happen pretty seamlessly. Everything works. So now let's switch to computer 2. Here's computer 2. They also have a change to merge example. And let's pretend this person isn't fetching first, isn't thinking first. They're just going to try and add their change to the GitHub repository. Added code to end of file. And let's try to git push. And I'm actually going to clear the screen first so you can see this command, what happens a little bit better. So here's git push. Right now our repository is communicating with GitHub. And you see we have this error message appear. And the error says it failed to push because the remote repository contains work that we do not have locally. And it explains a little bit more here, but ultimately it says we need to do git pull first. And the logic here is thus. Really, person 2, now differs from the version on GitHub, the sort of live version of the code. And it's up to person 2 on computer 2 to resolve this issue by pulling the updated code down locally and sorting through any differences. We don't want to sort through the differences on the cloud. That would be messy. The code on the cloud wouldn't work for a little bit. We just don't want to do that. So we can do git pull, and I'll clear again here and see what happens. And one of the great things about Git is it's very verbose. So these messages are giving us a lot of information. So here we see we've pulled, and you can see right here it says auto merging. So if you remember, even though we edited the same file, we edited different parts of the same file. And so Git was able to actually solve this for us and interleave together the different bits of code. And we can see this now if we go look at computer 2's merge example. You see we have this new section up top, and we have this new section at the bottom. So Git was really great for us it solved this problem for us. As a user, you probably want to manually check this, because if it was code, things could be dependent on each other. There could be something that you need to actually change anyways. But right now, you'll see if we run git status, everything seems fine. We can do our git add, git commit, resolved merge conflict. Well, it's not really a merge conflict. I'll just say merged in changes, and I'll do git push. And actually, I don't think I actually needed to do that add, because you can see it was already green. So I think I actually could have just done a git push, but I'm so used to that paradigm that, I did it. But no harm done. We've pushed things up. If we clear and we run git status, we're told our branch is up to date. If we look on GitHub online, on the GitHub playground, you'll see this example is there with both sections. And now person 1 is actually behind compared to person 2. And just for the purpose of the example, we'll say person 1 is smart about it and gets themselves resynced. So I'll just do git pull over here. All right, so that's example 1. Everything was really easy. Git could solve the problem for us. Let's go on to example 2, where computer 1 and computer 2 actually end up changing the same bit of code, because that's going to be a little bit harder, and that's where things can get a little bit more confusing. So let's again do this manually, and let's pretend that both people are reacting to these 2 lines of code in the middle. This is an interesting analysis that I'm writing now. Well, let's say person 1 doesn't buy it. Person 1 thinks this analysis is really stupid, and they want to update the repository accordingly. This is a really dumb analysis that we shouldn't have done. You wrote it. We should cut it. All right, person 1 is not a fan. We'll save that. Let's say person 2, however, kept working on this analysis, and they really loved it. So they said, this is an interesting analysis that is even better than I imagined. I'm writing it now, and we'll work on it all year. All right, this is a conflict in every sense of the word. So let's see what happens on GitHub. Again, we'll have computer 1 first take care of updating the repository, and they're not going to run into any trouble. So I'll do git add, git commit, message, added information on bad analysis, git push, all right, and let's switch to repository 2. I'm just copying the file paths here because it's a little bit faster for me instead of just typing. But now we're in computer 2, and let's add our other example. If you remember this even better than I imagined. So person 2 will git add, git commit, added more details on awesome work, and they'll do git push. And again, I'm going to just clear this out first so you can see what happens. So we've tried to push. This is the same message we got before telling us we need to pull down first. So let's do that. Git pull. And now Git will try to automatically merge these changes together for us. However, it's not going to be able to do it. And you can see here where last time it said auto merging, it sort of worked. Here we get this conflict notice. And we're told pretty explicitly there's a merge conflict in the file, merge example.txt. Automatic merge failed. Fix the conflicts, and then commit the results. All right, and if you do git status now, you'll see both modified. I can't just recommit this. I actually need to go do something about it. So what do we do? Well, computer 2 can just open up this merge example, and we see that Git has actually aligned things for us so that we can try and resolve this conflict pretty easily. So we will actually see in our file for any merge conflict both potential examples of the code. And it's separated by this head, this tail indicator, and these equal signs that show us the cutting point between the two. So now person 2 can solve this. And in this case, looking at it, you'd imagine person 2 would call up person 1, talk about why they have a difference of opinion between the analyses, and come to some sort of conclusion. So you could pick all of one thing, you could pick all of the other thing, or you could come up with something totally new based on the communication that happens. So let's have that third option happen and say, this analysis is okay, it gave us some insights, but we might want to try another approach, right? We'll save that. This is the solution to the merge conflict. Note, we got rid of the head, the tail, and the equals. That's how Git's going to know we've solved this. We'll close out. And we can return to our normal workflow. We'll git add, git commit, resolved merge conflict to, I don't know, you include some information here. Solve issue, right? And now, when we do git push, we're not going to get the same issue. We've told Git what to do in this situation, and it knows we've handled the issue. Git status, everything's clear. When person 1 goes back to the repository, they'll see this just like any other update. So person 1 can run their git fetch. They'll notice there's been a change and that they're behind. Here's this notice, behind by 2 commits, can be fast forwarded. Person 1 will do git pull. And now from this, everything will be up to sync. So I hope this was helpful. Let us know if you have any questions, and we're happy to chat more.